Good evening. So now for something very different. I appreciate, first of all, everybody sticking around a little bit later. I know that we're just a little bit off the schedule. That's not a problem. I guarantee it. My name is Jewell. I'm founder and CEO of Codenvy, and I'm also project lead for an open source project called Eclipse Che. Is there anybody in here that has ever heard of this project? I know this gentleman has. One person. All right, good. It helps that if you haven't heard about it because you get a little bit of education as well. Interesting background on my career. 25 years in technology, computer science guy. Started off at BEA in the 90s, wrote books on Java, traveled the world, worked on all sorts of great projects in the first .com boom, and then I decided I wanted to make some money, went into management. That was great, grew the corporate ladder, made a lot of money, decided to spend it, lots of recreational drugs, partying too much, and got sick. Super sick in 2010. I was out of commission for 9 months. Recreational drugs, bad. When I got better, all right, moral of the story, bad. Drugs, bad. When I got better, I realized, management, not so much for me. I wanted to reacquire my technology skill set. This was very important to me. I used to be a pretty good programmer. I wanted to reacquire that. My particular programming language of choice was Java. As a lot of you guys roll your eyes into the back of your head, Java has its merits. I enjoyed it a lot. So I sat down with at the time, the Eclipse IDE, very popular IDE at the time, Tomcat, a big popular Java app, MySQL, and I just wanted to do some hacking and get this stuff to work. And after 3 days of work, I couldn't get it to compile. And I'm sitting here going, okay, maybe I did a little bit too much of the white stuff at the time, but I used to have some pretty good skills, and I couldn't understand why it was so difficult. And I got very frustrated with this. I was incredibly frustrated, and it would have been very easy to just walk away. And this particular issue of getting started with your development environment is an issue that every developer on the planet faces. No matter how good you are, you might try to act like you just push a button and everything just magically works. It really doesn't. And in that moment of frustration, I was just like, why doesn't this stuff just work? Why can't I just have a link? I click on the link, and everything that I need to edit, build, test, analyze, debug is just there, right? And in that moment of frustration, and I was very frustrated, I was just like, why can't anyone, anywhere, at any time contribute to a software project without installing any software? Cloud technology had advanced far enough. Everything that we need to do this was there. So we started working on this about 6 years ago. We eventually created a company, and we got an open source project around that. And it was this basic idea. Let's let anybody contribute to a software project. So what does that mean? What does a contribution mean? Well, a contribution from a developer point of view requires 3 things. You're going to need an IDE, you're going to need some project files that you're going to modify, and you're going to need a runtime. And in this case, the runtime is anything that you need to edit, build, test, debug, run, analyze your code, right? And a developer needs that runtime. It may be a production runtime. It may be a desktop runtime. We then conveniently require a workspace. And a workspace is a very important construct here. And that workspace basically defines the project files you're going to work on and the connections to the IDE and the runtime that you need, right? But what's interesting is that we set this up on our desktops. You go about installing the IDE of your choice, and you create a bunch of project files, and then the runtime that you need is the one that's most convenient for you. And that runtime tends to be localhost. And so as developers, we populate our localhost with all the tools that we want. And there's lots of things that we do to try to organize our localhost to make it easier. Some of us use Vagrant. Right? Some of us use VirtualBox or Fusion, pull out some more hair along the process. Docker came along 3 years ago and promised us even betterness, right? They said it's for both production and development. That tagline that they keep talking about, development, right? So sure, great, Docker, I'll still go and use my containers. And when you want that development environment, you still have to write a command line that looks like this to pull down. Maybe you have a Docker compose command to pull it there, right? But you still have this runtime. And it's interesting. I was like, OK, you can get this set up, and you can get it working. But what if you want to give that workspace to somebody else? Right? What do you have to do? Or what if you want to move that workspace to a second machine? Or what if you even wanted to share this workspace with its runtime on localhost? And the problem is you quickly run into all sorts of issues about sharing the workspace, controlling it, scaling it. And it's just not possible. And so when we started thinking about this, we were like, OK, if we want to let anybody contribute at any point in time, anywhere, what we need is a universal workspace. That workspace needs to be able to move from one location to another, and it needs to be clonable, it needs to be portable, and accessible by anyone at any point in time. Eclipse Che is an open source project started about 3 years ago in conjunction with a number of different vendors. SAP's involved, Microsoft's involved, Red Hat's involved, IBM's involved, Samsung's involved. We'll be making a big announcement with them. It is a next-generation Eclipse IDE, full-on IDE platform. But at its core, its entire purpose is to make workspaces universal. And let me explain what that means. And Docker is essential to how we do that. First of all, we redefine the workspace so that it not only includes the projects, but all of its dependencies. And so inside the workspace is everything that you need to make a contribution, which includes the IDE and its runtime. So first, workspaces bring their own runtimes. You could have one runtime, or you could have many. Out of the box, Che uses Docker as its runtime provider, but it could be a local host runtime, an SSH runtime. You could provide a VM runtime. You then take the projects, we mount them into the runtimes, and then the workspace itself serves up its own IDE. In this case, it's a cloud IDE embedded inside the workspace itself, runs entirely in the browser. I'm going to show you what this looks like. We designed it to be like Sublime and IntelliJ. The workspaces also embed their own SSH daemon so that you can connect from your desktop IDE if that's your poison in that case, right? And then Che provides a server capability so that you can host multiple workspaces together, so that your desktop IDE or the browser IDE can connect in. And we then take some other technology projects, Java development, JDT, Python scripts, Ryan, which is a type of editor, and package it up into a new kind, a simpler kind of developer experience. When you do that, the workspaces are now shareable. They're controlled by a server. Multiple users can share one workspace, or they can have a server with multiple workspaces that they're consuming. And then the workspaces are portable. They can actually move from the server, one server, to another. And they can move into offline mode, right, where it's actually running on the desktop or off into the cloud if that's what you wanted. And also, the workspaces are programmable. So you can actually connect into the workspace, deploy plugins into them, create new workspaces, modify the projects within them, all through a RESTful API. So this is the architecture. And we have been working with Docker for about 3 years. And this is an opportunity to see a different kind of side of Docker to make these workspaces portable. So Che is a tripod architecture here. There is the browser, the Che server, and the workspace itself. And all three of these things are communicating with one another. Now, we think of Che server as the workspace master. But what essentially happens is a developer comes along, connects to Che, and says, I'd like to have a workspace. Give me a workspace, please. And we go off and provision one. Now, that workspace has embedded runtimes. And so we start launching the Docker containers automatically. And those Docker containers themselves, when they come online, we put Che agents inside of them. And I'll show you what these agents do. So when the workspace comes online, the agents are there. The agents connect back to the Che server. The Che server communicates back to the browser and tells the browser where your workspace is. You're on this node, or you're on that node, or this is where you're at. And then the browser has a direct relationship to its workspace over WebSockets. All right? So let's take a look. All right. OK, if that's not even remotely readable. When does it get to be kind of interesting back there in the back? Thumbs up? Oh, right. Web app, completely responsive. Zoom in, zoom out, automatic. Love that part. All right, so let's create a new workspace here. I'm just going to create one from a sample project. We have this concept of stacks. And the stack defines the runtime that you want embedded inside your workspace. Now, we have these ready-to-go stacks. You can pick from a stack library. Or you can write a custom stack, which is a Docker file that you provide, or a set of Docker files. In this case, I'm going to do Java because, raw Java. I don't know Go yet. That's OK. We're going to give the workspace. Workspace has its own runtime, so we're going to give it some RAM. And I'm going to do a web app, which is a template here. And I'm going to create this project. I'm going to zoom out just because it's just for now as we create this project. And off we go. And what's going on here, now I can zoom in, is on that little crane animation, the workspace has been created. The workspace in this case has a single runtime. It is booting up. This is a Docker container here. If we didn't have the image, I already have the image cached, but if we didn't, it'd go off to Docker Hub, grab it. If I had provided a Docker file, it would build it on your behalf here. And then after it's done with that, it is starting the agent. And the agent is started. Ignore that error message. It's fine. And after it says the workspace is booted, it says, good, you can now open the IDE. And so here's the IDE completely in the browser. There's a URL up here which basically says it is my IDE on this workspace ID. It is connected to that workspace. And so my browser is connecting off to that workspace that's on my server there. And I've opened this up, and I can open this file. And we've got a nice editor here. And the next question that comes up is, OK, how responsive is this? I'm glad you asked. All right, so we'll go ahead and get in here. First thing we'll do is we've got a terminal into our workspace. I could run Midnight Commander in this if I wanted to. I'm going to projects right now. And this is the web Java Spring project. I'll touch Docker Meetup. There. And where is it? Where is it? Doing it too big of a, there's that file that I just created. So the projects have been mounted, and I can use the terminal from right within that, and it modifies the tree. So that's all good. And as you can see, when I started in here, it recognized that this was a Java project. It had Maven. And because it had Maven, it automatically started downloading all the dependencies. I didn't have to ask it to do so. So it's applied the Maven project type to this, just like you would in an Eclipse or an IntelliJ IDE. And so here we go. We have this Java file. And I can come in here, and I can start doing things like control space. And here's autocomplete on this. And it's just as fast as anything as you have in IntelliJ. And the reason being that it's just as fast as IntelliJ or any other IDE is that all these commands are running inside your workspace in the Docker container. So what's happened is we've launched the workspace runtime. Inside that runtime is an agent that is a RESTful service that provides commands or interfaces to all these IntelliSense commands. And when I do like autocomplete, like control space here, what's happening is that request goes to that agent. That agent then executes it using native JDT libraries against the Java code that's there. So it's running localhost speeds inside the container. And then we take the result, put it into a RESTful command, and send it back. So it gets the full experience in that regard. And in here, I could spend a lot of time, but we've got all the sorts of same capabilities that you would have with the Eclipse IDE. There's refactoring, method level, instance level. I could do doc outline, Java doc insertions on this. There's probably like 150 or so IntelliSense capabilities. There's a built-in debugger. I could debug locally. I could debug distributed. And it's all at the same performance speed that you have on your own. So the idea here is that there's a lot less configuration. So now I need to compile. All right. And what I'm going to do is I'm just going to do a build and run. Now, we've changed the nature of the configuration. Because your workspace provides a runtime, the entire configuration of your compiler, your analysis tools, the debugger can be provided in with the runtime. So the right JDK and the right configuration of that was embedded in the runtime. And we have this concept of commands that are up here that you can define. And you edit these commands. And essentially what commands are is they are processes that get injected into your workspace runtime, and they execute for you. So in this case, I ran that command, and it was just this fancy Maven followed by launching a Tomcat. And off it went. Down here, you can see all the execution of that. And it looks like, in this case, the Catalina, it compiled successfully, and Tomcat's running. And it gave me back a URL. And there you go. That's that web application project that we started off. So in a matter of a couple of minutes here, we started off in a browser. We picked a template project. We picked the runtime that we wanted for it. We got it booted. We compiled it. And now we run it here. And if we wanted to, and I had a little bit more time, I could launch the debugger. And we could do breakpoint level debugging in here. And on the debugger, we support C, C++, Go, Python. There's like 12 or so languages that we support with debugging on this. So all sorts of good stuff. All right. All right. So interesting architecture. What does this mean? What's next? If we had more time, I would take you through some of our Docker files to show you what we do to take a standard Docker-based image for Java or for PHP and convert it into this workspace that can launch on demand. But I actually wanted to take just 1 minute and talk about my company, Codenvy. And I told you that at the beginning, I had this frustrating story about why doesn't this stuff just work? And Codenvy was born out of the ideas of that. Now, Eclipse Che is completely free. It's completely customizable with plugins and extensions. We've got lots of amazing projects going on. There were over 100,000 downloads of Che in the last quarter alone, and it was announced in January. We picked up almost 3,000 GitHub stars in the past quarter. So there's a lot of momentum and interest in it. My company, Codenvy, we take Che and we make it on a distributed swarm cluster so that you can run up to 100,000 concurrent workspaces on a distributed set of nodes and let developers have access to that. And we do it on a multi-tenant infrastructure there. But also with that, we then integrate the workspaces with your issue management, version control, and Jenkins CI system so that the workspaces are generated on demand from within those tools. So that as you're looking at the bug or as you're looking at the failed job, you can just click a link and get the workspace. And so we do this with a technology called factories, which again are in the URL form. And they essentially are intelligent ways to load or create workspaces and securely onboard developers. So that dream that I had, let me just go to this web page here. And this is a beta site that we're running with some next-gen stuff. And so no, that's not where I wanted to go. Let's go to GitHub, Che samples, see pet clinic. Here we go. So here's an open source repository. On this repository, let's say, hey, I'd like to get a developer workspace so that I could work with this project and make a contribution back. And so here we've got that button, and it's going to ask me for my login credentials. And in this case, I can just use OAuth, and I'll provide the OAuth capability. But other than providing some credentials and an OAuth capability, everything else is done. So if this had been an incognito window without me ever knowing anything about that project or what it takes to compile it, I click a link, and off it goes to create the workspace. It's creating a now dedicated runtime for that. It will clone the project source code, whether it comes from a private repo or a public repo. It'll set the project typing. It'll install any IDE plugins that are needed there. And then it will also populate all the commands that are there. And also, in this case, it auto runs the command, so I can just click the link and prove that it compiles to myself. And this is also set up with pull request capabilities directly in here on the side. So if I wanted to make any changes, I could either commit right back to that repo if I have privileges, or it'll automate a pull request back without having to set anything up. So this is back to that scenario where I'd gotten sick. Why can't it just work? You just click on a link, here you go, and you have at it, and it's working here, right? So that's a lot of fun. If you are responsible for an open source project, and you want this capability, we will give you unlimited, for you and your users and your committers and your contributors, unlimited 4 GB workspaces for free if you badge a repo with that button on it. Right? That's a good deal for us. We get some marketing out of it. You get more contributors. So that's great. Eclipse Che is about productivity. It's about enabling developers. It's about helping ISVs. We have a lot of partners who embed this. SAP embeds this as part of the SAP HANA Cloud. If you think about the SAP IDE, we'll be making a big announcement in Samsung's keynote. They're going to use this as an IoT IDE. It actually runs on the device itself. So you plug the device in, and up comes the IDE on your browser. Red Hat uses it for an OpenShift IDE. We have a Kubernetes plugin as well. So lots of stuff going on with that. And with that, in about 20 minutes, that was the rapid fire version of it, and open it up for any questions that you may have. Yes, sir, in the back. How do you free up the resources? You got to stop the workspace. And you can either just stop it and kill it in its entirety, or you can snapshot the workspace, which creates an image out of it and puts it in a registry. Yes?
Is the workspace mapped to a single container or
The workspace itself has what we call a dev container, which is the dominant container that has all the dev services. But the workspace can contain environments which have as many containers as you want to define to it. So you can have a multi-container workspace if you want. But there's different classifications of the runtimes. There are the runtimes where we inject our agents and mount the projects, and other runtimes which are intended to be read-only, where they only get, say, like project binaries, and they don't need the agents inside of it.
So what if my PC crashes? What happens to what do I have working on?
The workspace is in a server somewhere.
So it's not going to be in the Docker container. So you're not saving anything in the Docker.
The browser is a dumb client in this regard.
Okay.
Yeah.
So everything is so we need to configure the workspace, the repository, the report server.
Yeah, you run Chase as a server somewhere, and it's a server, right? So if your client fails, you just reconnect, and you're good to go on that. Yes, sir.
Can we split like RabbitMQ, Postgres?
RabbitMQ, Postgres, yes and yes and yes. Yep. We're going to be putting up a site tomorrow on this beta. We've got about like 30 of those factories. So Vertex, Wildfly. We've done it with a lot of the pivotal technologies. We run Che and Che as well. So you can run a Che inside of a Che and do development with that. So all sorts of scenarios there.
How much memory do we need?
Well, how much memory do you need? So the Che server itself takes about a ½ gig. It's really lightweight and thin. Each workspace is the allocation on that. Now, the agents inside the workspace are about as small as like 200 megabytes of RAM. But then it really comes up to what the developer needs on that. Now, if you're doing a full Java workspace like I do here, if you've got a monster project, the JDT, which does all the IntelliSense for that, IntelliSense libraries are just notorious for being memory hogs. So like if you had a 50,000 line Java file, that could get to like a gigabyte of RAM just for the IntelliSense part. Yeah. Anything else? Yes, sir?
So yeah, along these lines, can you tell us a little bit more about the Che server hosting and project hosting, or can we serialize these projects physically?
So the project inside the projects themselves are treated separately than the workspaces contents there. So
That's really what I meant to say.
yeah. So the projects in Codenvy, which we are an elastic version of Che, we actually use an rsync protocol to keep the projects saved on a long-term storage, and they can also be cloned from a repository as well. So that's how you deal with the projects. Now when you deal with workspace state, like in this case I had a Maven repository and I was downloading all those libraries, you don't want to stop the workspace, start it again, and then have to re-download all the same libraries again. You want to maintain the state of that. So it comes configurable to the admin. The one configuration is that some of our clients actually do want the workspace to be wiped out, and so they intend to run the workspace as a always-on scenario. In other cases, they want it to preserve its state. So the best way to preserve the state is you actually snapshot the workspace, which then we run, we create a Docker image out of that with all of its state, and then we put it into the registry, and when you say restart my workspace, we are actually creating the runtime from the image state as opposed to the previous one on that. And then we just mount the projects back into that, and you pick up where you left off.
So you serialize the Docker image?
We serialize the Docker image today. And what's great is because the developer can provide their own workspace runtimes, you know, a developer can say, here's my Docker file with all the stuff that I want to start off with, and you can have that image cached locally, and so you just create the container right away and you go to town with it. Yeah. Yes, sir?
So with large number of these workspaces, do you run into layer collision when they push?
When you large number of workspaces, I run into what condition?
You snapshot and then you push them up, you run into layer collision.
Run into layer conditions?
Collision.
Collisions. So far we haven't. We have about 500,000 users on codenvy.com. So we do okay with that. But the reality is that workspace snapshotting doesn't happen as often as you may think. Most people, once they have a workspace running, they're just leaving it running. So the bigger challenge on scaling it is memory management. Right? Imagine having 100 developers who each want 16 gigabyte workspaces, and also with it this easy to start workspaces, you run into developers like, oh, I want 20 workspaces, right? So the RAM configuration is the big challenge. What we do is we run a Docker Swarm cluster underneath, and we make it easy where you just say add node, remove node, and then we take care to distribute the workspaces appropriately on that. Yes?
Do you have to do any kind of a tooling? So for example, you talked about SAP HANA, right?
Yeah.
The SAP HANA plugin of the UI.
Yeah.
In order for you to enable this on the HTML plugin for this, do you have to go through any changes, or does it automatically translate?
Yeah, so his question was, what's the plugin model for it, and how does the end user activate it, right? In this particular version of Eclipse Che, you need an assembly that has all those plugins pre-compiled into it. And so we've built Che as an SDK, so different ISVs can take it, put the plugins that they want, and then create their own assembly from it. In a couple of years, or maybe a year, we'll work on having dynamic deployment of plugins. It's a little bit trickier.
So I cannot take a standard Eclipse Che and go deploy an SAP HANA or any kind of a plugin that I want, not today.
Sure you can, yeah. If that plugin's available, there's a way that the end user takes it, adds it in, it builds a custom assembly off that, and you restart it, and it includes that plugin. It's a compilation process right now. It's not a, activate it at runtime. Our plugins, by the way, are very different than Eclipse plugins. This is not like your grandfather's plugin. A plugin in this system is a distributed plugin. So when SAP built their plugin, there is a portion of the plugin that goes inside the workspace. There's a portion that runs in the Che server, and there's also a portion that runs in the browser. And so so it's a single zip file that you deploy, and we break it apart and then push it into each of the places, and then we take all the client-side ones and we compile it into one JavaScript app. So this is we haven't made that fully dynamic yet. We have to do that as a compilation process right now. We'd love for you all to get involved. I'm going to hang out here for the rest. I know it's getting late on that. But lots more testers. Please, more contributions. Use it for your own projects. We'd love it if you did that. Thank you, guys.